In this video I'll run through how to program a relatively simple 5-axis part. So if you have a 3D model you want to work off of, you'll go into the 3D-5X area here. So oftentimes the temptation is to go over to here to open up your model, but over here you can only pull up DXF, DWG, IGES and such. So for our models we'll go into the 3D-5X. You'll specify your material. So we're going to say this will be out of stainless steel. We'll use a 1440 nozzle combination. You don't have to specify the thickness. IGEMS will look at the cross section that the stream is actually going across to determine the feed rate, and then ultimately the feed rate is determined by the machinability of your material and not by whatever thickness that you choose here. If you are going to nest the part, you'd want to have this set to the proper thickness later, but for now we can just use that. So now we're in the 3D world here. So down the bottom you've got options to do things like turn your grid on and off. You can activate your snaps with the F9 key, or down here if you want to have various snaps turned on. So we'll go up top left hand corner here and we'll grab a sample, and we'll grab this one here. So depending on how the part was drawn, may come in oriented not what would be the ideal orientation for cutting this on the machine. So of course the grid represents your table surface basically. So what we'll do here is on our cam tab we have this ground option, so you can click on this and you can down here at the bottom the various options that you can choose from to tell IGEMS how you want this oriented on your table. So you can just hover, in this case since there's a nice flat surface here on the bottom, you can just click on that and then that will lay that down here on the table. So we've got a bevel cut on this side and then 3 straight edges, and the slot is also straight. You can also spin this around the Z-axis depending on how you want this oriented on the table, or you could do that back in the 2D world. This orientation here looks fine, so we'll just go ahead and start picking some edges. There is the auto option that you can try as a first pass to see how it does. So it'll look at the see what sort of edges that it can find in the part and then try to create tool paths based on what it sees. So if you can specify what you want for lead-ins and lead-outs and such, and we'll go ahead and click on OK here and see what it did. So in this case here it's not too bad, so we can do things like click on this rapids button. So right now it's showing us rapiding all the way up to the top of our Z-axis travel and coming down. So if you click on the rapids button you can tell it how high to lift between cuts, and then we can do a simulate, see what it's going to do here. So over here you can choose your style of cutting head that you have. So we'll choose our abrasive cutting head here. So these can be customized. If you click on this little edit button here, if you have a different style cutting head, you can go through and adjust these numbers accordingly. And we'll click on start. So here we can see the angle that is going at through the part. So here we are tilting over to 30 degrees. Slow this down a little bit. So it goes to vertical, and then we'll start tilting over back to 30 degrees to come to there. So that could be fine, but you might want to change things. Maybe you want your lead in, lead out at a different position. You might not want to lead in on going into the bevel cut. You might want to do this a little bit differently, as far as maybe do the outside as 2 separate cuts where you cut the bevel cut first and then you stop and re-pierce and vertically cut this. Sometimes you'll get a little bit better cut result if you do that. So if you want to change things like that, you can go to this toolpath area here, and now here it shows the 2 different cuts that are in this part. So if you just want to change something like length of lead in, lead out, you can do that without having to change the tool path. You can just click in the box and change things accordingly. You can change quality on the cut. If you would want the outside cut to be done faster or slower, you can come down here and change that. But let's say we want to change our lead-in position entirely, which you can't do through here. You have to delete the cut, and then we can click on the plus button here to re-add our toolpath, and then it prompts for upper curve. So when it did the auto command, it automatically found curves that are in the model. So we're going to choose this as our upper curve, and then where we want to pierce, I'll pierce down here. And then for the end point, I just hit enter to tell it to go all the way around the part, and then which direction you want to go around the part, clockwise or counterclockwise, and then you left click to indicate which direction you want to go. And then the lower curve is here. And then what we're telling it now is information about the lead in and lead out. This red circle indicates the radius of potential lead in position based on the right now the default lead in length. So if I move my mouse around, when it hits this tangential point to the cut, it'll kind of lock into that position, and if that's where you want your lead in to be, you can just hit enter. And then for the lead out, same type thing. As you move your mouse around, it'll lock in at that tangent point, and then you can just hit enter there. And that's the lead in and lead out length, which again could be changed if you wanted to click into this box and change that. So now we can click down here at the bottom, and this will just give us a simulation of this cut. Okay. And then if this were a smaller part, you didn't want to fall into the tank, well, let's go ahead and measure this. We can go to our cam tab, we can measure this. So if we measure from here over to here, we see that this part is basically just under 4 inches, which could potentially fall into the tank. So if we wanted to leave a tab on the outside cut, we can go back to toolpath and go back to this cut here, and these cuts can be renamed if it helps when you get into a more complex part with more cuts to keep things straight, what's what. So in our lead in lead out area, we have this choice here to use overcut, and if you put a negative number into the overcut box, then it will leave a tab. So right now we've got the lead out but no overcuts, so we tell it to use overcut and then put a negative number in here, like let's try 40 thou, which will have to make it a little bit shorter because now we'd basically be stopping right there where we let in, so we'll make this 80 thou. So with the stream diameter being about 40 thou, we'd probably be left with a small amount of material there, so that's how you can specify if you want to leave a tab on a part. Could also shorten up your lead out in this case here and make this a little bit longer. So these two numbers here can be adjusted in this case when you're doing it on a corner to adjust your tab width. Or if you wanted your lead out to go at 90 degrees, you could do something like that and then adjust this. Now, another thing is, as I mentioned earlier, you might want to do this outside cut as two different cuts, because if your cutting head, your 5-axis cutting head isn't perfectly calibrated, as the head is tilting over to this angle, you might see a little bit of a deviation in the top of the part. So to kind of cover over that potential error, we can just delete this cut and we'll program the outside as two separate cuts. So we'll program the bevel cut first, so we click on our plus button again here, upper curve, and then where we want to start and where we want to end, and then we want to do just this portion of this cut here. So when that's highlighted red, I left click, and then lower curve, I click on the lower curve down here, and then give it lead in again. So I just move my mouse till it locks in there and hit enter, and then come up here, wait for that line to lock in and hit enter again. So right now we've got tilted piercing turned on, so it's going to tilt over to this 30-degree angle and pierce. Sometimes on abrasive cutting, especially as you get thicker, you might want to do a vertical pierce, and then it'll tilt over as it's doing the lead in. This material is relatively thin, so we can do the tilted piercing. As you click that box, you'll see that this blue line here, which represents the trajectory of your lead-in stream changes, so you can see where it's going to go. And then you'll see we have nice straight lines here, so that should be a nice straight bevel cut there. So we'll get to the end of the cut there, and then we'll add another cut. So we'll choose this as our upper curve now again. This is where we're starting, this is where we're ending, and we're going this way around the part, so I left click, and then lower curve, click on this, and then again lead in, and then lead out. So we just want to make sure that the lead in and lead out are long enough that they're going to pass by where the bottom of our bottom bevel was here. So if I hover my mouse down here, in this case here, it'll line that up basically with the end of that cut. And then right now it's showing this being cut at an angle. I'd prefer this just to be a vertical cut. So it's basically picking up the angle here to do the do that cut here. So up here I can change this, and if I change this to fixed, then it'll change that to be 0° angle for that cut. And then you can see where the lead in and the lead out are. And if I want to make sure that the lead out is going to get beyond there, I can add a little bit to that. We'll make it 1/4 inch also. And when you do a cut like that, you just have to make sure that the kerf is on the appropriate side. Since we're going clockwise around that outside cut, we want to make sure that that is set to left, which it is. If it were set on the wrong side, you wouldn't see the red lines indicating the stream trajectory, but you can just click into here and change it to the appropriate side. You can also uncheck this box here if it makes it a little bit easier to see what you're working with. And that looks good, so we'll go ahead and click on close, and then we'll just readjust our rapids, bring those down. And then finally we'll set our 0, point on the part. So if we're just cutting one part, this would be where we would start the nozzle. So right now our 0, point is down here at the top of the table, which really wouldn't be that convenient to get the nozzle to. So you've got the choice here for 0 point. So if I want my 0 point to be lower right on the part, I can just hover over that corner since I have my snaps on and put my 0 point there. If I wanted my 0 point to be lower left on this part, start this command again. If I right click, I can choose this box option, and draws basically a box around the model. You can see that black line there, so I can just hover near that corner there, and then that would put my nozzle above the lower left hand corner of the part there. And we can do one final simulate. And if that all looks good, then you can click on this to create part. If you click on this button here, it'll pull the part name from the file and use that for the name of the part. You can adjust quantity and such here if you need to. Now it brings it back into the 2D world. So if we want to cut this, we use our order 1, 2, 3 button here. Select this. So important thing on any of these 3D 5-axis parts is when you bring it back here, you want to click on this part button, and then it'll pick up what the thickness of the part is and put your 0, point where you had chosen it in the 3D world. So once you've done that, then you can click on close, and then now I've customized my toolbar here. This normally says process. I've changed it to say make CNC, but click on the blue process button, and then you can come in here and you can do a simulation. So now we can click on the simulation. So over here we're moving up 1 inch, rapiding over, and then coming down to our piercing height, cutting this. So in this preview mode here, you can stop and go fast forward, step back and forward, change your speed and such. Now if you decide that you want to change anything to get back into the part, come back into here, double click somewhere on the perimeter of the part, and then that brings you back into the 3D world with that part, so then you can go through and change anything that you might decide that you want to change. And then when you exit out, click on Create again, and you can click on this button. It'll update the existing part. If you're doing some experimenting and you want to have a duplicate part but just has that one change, you can click on New Part, and then you'd have 2 parts when you get back into the 2D world. And then you would just go back again, preview it if you like, or click here to make your CNC file. If you have any questions, let us know. Thanks.